Hello students, welcome to the class once again. Last class we started with relative motion and we understood about the river flow problem. Now today we'll go ahead and we will see Rainman problem. Normally when you are standing on ground and rain is falling, you hold the umbrella in the direction of rain as it falls. Now suppose you are walking or let's say you are running, you need not to hold the umbrella in the direction as you were holding earlier. You have to change your direction. See what I mean to say? Suppose let's say rain is falling along this direction. This is the velocity of rain. And let's say it's falling making an angle of theta with the vertical. Suppose you are stationary and you are holding an umbrella. So you have to hold the umbrella as per the given direction shown. So you'll be holding the umbrella in this way. That means you have to hold the umbrella making an angle of same theta with the vertical as the rain was falling, making an angle with the vertical. Now suppose if you are running or let's say if you are walking with some speed, you do not have to hold the umbrella in the same direction. What I mean to say, let's say you started moving with some velocity. Let's say your velocity is Vm, that is velocity of man, and now you have to hold the umbrella. You will not feel that the rain is falling with the same angle. You will feel that this time you have to hold the umbrella in a direction different from what it was earlier. Let's say this angle is given by phi and rain will appear to you falling making an angle of phi. That means this is the velocity of rain with respect to you. So I'm marking this is velocity of rain with respect to man. In this direction you have to hold the umbrella when you are moving with some speed. Now let's come to the initial case once again. Here the rain was falling. I have given it a velocity Vr. Now remember when we are moving, we need not to express the rain's velocity as Vr. We have to express the rain velocity as observed by you as Vr/m. Now let's see what kind of problems can come based upon this. Before that, let's see the triangle rule that will ease the calculations by learning Rainman problem. Now see, actually the rain was falling in this direction. This is the velocity of rain. Let us say you moved along this direction. This is the velocity of man. Let's say you are moving in this direction. Now velocity of rain with respect to man is given by the equation as already I have taught you in the previous class. This will be equal to velocity of rain minus velocity of man. This will be the equation. Now you see, if I want to do this vector subtraction, I have to take negative of velocity of man. That will be equal to this. This will be minus velocity of man. So if I want to find the resultant of Vr minus Vm, the resultant will be lying somewhere here. This will be the resultant of Vr minus Vm. Now let me mark the angles. The rain was falling at an angle of theta with the vertical. Finally, you have to hold the umbrella making an angle phi. The angle with which you have to hold the umbrella, that will be given as phi. So this is the angle that you have to hold the umbrella. Now with this diagram, you will be having the idea of how to find out the angle with which you have to hold the umbrella with respect to the vertical. Let's come to a problem which will simplify our understanding. Let us say it is given that a man has to hold an umbrella making an angle of 30 degrees with the vertical. So first information given, a man holds an umbrella making an angle of 30 degrees with the vertical. Holds an umbrella making an angle of 30 degrees with the vertical. Making an angle of 30 degrees with the vertical. That means rain is falling making an angle of 30 degrees with the vertical. Now what he does, he starts running in such a way that he feels that rain is falling vertically over his head. He throws the umbrella. It's given that he throws the umbrella and starts running he throws the umbrella and starts running with a speed of 10 km per hour and starts running with a speed of 10 km per hour. See, it's given that now he finds rain is falling vertically on his head. It's provided, the next statement is, now he finds that as he starts running with a speed of 10 km per hour, he finds that rain is hitting his head vertically in the vertical direction. He starts running with a speed of 10 km per hour. He finds rain hits vertically over his head. Vertically over his head. The question is, find the velocity of rain. First question is, find velocity of rain, and this is velocity of rain with respect to ground. Find velocity of rain with respect to ground or road, you can think of, that is also the right way, with respect to ground. The second question is, find velocity of rain with respect to man. So the second question says, find velocity of rain with respect to man. This is the second question. Now, how to do these two questions with this given data, with this given information? See here, let's write the solution over here. First part, when he was standing still, see how, when he was standing still, this is his position and he has to hold the umbrella in this direction, that is making an angle of 30 degrees with the vertical. That means rain is falling along this direction and rain is making an angle of 30 degrees with the vertical. So this is the velocity of rain in the given sense. Now the second data is given that he starts running, and as he starts running he observes that rain hits his head vertically. So what I'm going to do, I'm going to mark man with a dot. This is man, let's say this is man, and the rain is falling. Let's say this is the velocity of rain. This is velocity of rain making an angle of 30 degrees with the vertical as he starts running. Now see, he will start running along this direction. This should be the velocity of man. You'll understand why. Now if you find velocity of rain with respect to man, that has to be in the vertical downward direction. So we have to mark minus Vm. This will be somewhat here. This will be minus Vm. This is Vm. This is Vr. And Vr and Vm resultant, as I told you, velocity of rain with respect to man will be equal to velocity of rain minus velocity of man. So we find that since it's given that he finds that they are hitting him vertically downward direction, so this will be the velocity of rain with respect to man. Now we got this diagram, we got this. We have to evaluate what is the velocity of rain with respect to man and velocity of rain with respect to ground. Now from this diagram you see, velocity of rain with respect to man is the resultant of this vector and this vector. Now you see that the horizontal, there is no horizontal component on Vr/n. There is no horizontal component. So horizontal component will be cancelled out of these two vectors. We have to consider this and this vector. So there is no horizontal component. The horizontal component of this will cancel out the horizontal component of Vm. So that is, from this diagram, first thing you can make out, Vr and its horizontal component will be Vr sine 30 degree will be equal to Vm. This has to be the requirement as we can see in the figure. So therefore, Vr will be equal to Vm divided by sine 30 degree, or we get Vm is equal to 10 km per hour. So 10 divided by sine 30 is 1 by 2. So 10 into 2 you will get 20 km per hour is the velocity of the rain that is the velocity of rain with respect to ground, as we have marked this as VR. We got the first information. Now the second information that we want, that is VR/m. We want to evaluate this. Now VR/m, it will be equal to the vertical component of VR. You can see the VR/m is the resultant of this and this. So this has to be equal to vertical component of VR. So let us find out the vertical component of VR here. Let me rub this question. Hope you have taken down. Okay. Now use the concept of vectors, and I have told you about the resolution of vectors. From there you can use the concept. VR/m will be actually, from the diagram you can make out, this has to be equal to VR cos 30 degree. And just now we have already evaluated the value of VR, that is equal to 20. So it will come out to be 20 multiplied by √3/2. This will be equal to 10 √3 km/h. So we got the velocity of rain with respect to man. I want you all to take down till here, and I will continue. Okay, now I believe that this problem would entail you a better understanding of the concept of Rainman problem. Usually many exams ask such kind of question based upon this. Let's say your competitive examination also, like JEE and medical, let's say the CBSE board also asks question based upon this. Now we will see one more pattern of question that may be asked in some of the examination. First one, let us take an example. We have a car in which a man is moving. There is a car, it's an open car. In this, a man is moving. He is driving actually this car. He is driving this car. Now, he finds that this is an open car. It's an open car. He finds that rain is falling in the vertical downward direction. So, as he is still, the rain will be hitting him. It's an open car. So, as the car is open, the rain will hit him vertically on his head. Now, he can drive this car up till some speed, let's say Vc, and let's say speed of rain is Vr. Now, with respect to rain, what is his speed so that the rain will not hit his head? And it's also given that this height of wind pane is given as h and this distance is given as d. This is provided. Now, as he moves, the velocity of rain will not appear to be in the vertical downward direction. That will change. What I mean to say with this, see here, as he moves, the rain will appear to him in this direction. This will be velocity of rain with respect to man. Just now I have told you. And this is velocity of car. To be, since we are using car here, so I will use velocity of rain with respect to car. It should be along this direction. Now, rain was falling in the vertical downward direction, but due to the motion of the car, it will appear that the rain is falling in this direction. Let us say this is theta. It will appear to him now the rain is falling at an angle of theta. So this will be angle theta. Okay, and it is given that this was his head. It's given that this is d and this is h. Therefore, you can see from this triangle, that tan theta will come out to be d by h. Let's write first this point. Tan theta is equal to d by h. This has been provided to us in the given information. Now, with what speed he has to drive his car so that he escapes himself from being wet by the rain? Let's draw the triangle. This is the velocity of car, and this is the velocity of rain that was actually with respect to ground. Now we have to mark what is the velocity of rain with respect to car. So velocity of rain with respect to car, if you see, the formula is VR minus Vc. This is the formula. So we have to just subtract Vc from VR. For that, if I mark V minus Vc along this direction, if I take their resultant velocity of rain with respect to car will be somewhat like this. Now see, just now I showed you this is angle theta, so this will be angle theta, and here you can make out from this diagram that tan theta will be equal to, you see, tan theta will be equal to velocity of car. You can see here we can displace the vector parallel to itself. This will be also minus Vc. So tan theta will be equal to Vc, magnitude we are talking about Vc, and upon Vr. So we got this. We got here tan theta was given as d by h and tan theta is equal to Vc by Vr. We can equate both of them and we will get the relation of Vc and Vr. So therefore we can write equating both Vc upon Vr can be written as d by h. Therefore Vc comes out to be Vr into d by h. Hence he should drive his car with this given speed so that he escapes from being hit by the rain, or let's say he will not get wet if he drives with this particular speed. He can even increase his speed and again he will escape himself. The minimum speed with which he has to drive will be given by this formula. I want you all to take down till here and I will continue. Hope you have noted down the Rainman problem and you would be having the understanding of how to solve such Rainman problem with this example. Now we have completed two parts. One, the river boat problem, the Riverman problem, and the second one, that is the Rainman problem. Let's practice some problem based upon our learning that we have done in two of the cases. Both cases are very important. So first, let's revise, let's practice problem on both. First one, let us say a river is provided and the width of river is 400 meters. So let us say a boat sails in a river with a speed of let us say 4 meters per second, normal to flow of river. This is given. Now it's given that the velocity of river flow is equal to 2 meters per second and the width of river is 400 meters. The width of river is 400 meters. The width of river is 400 meters and the river can flow with a velocity of, and river flows with a speed of, 2 meters per second. With a speed of 2 meters per second, we have to find out in how much time will he cross the river, that is he will move from one point of bank to the other bank. That is the time that we require. So find first time taken to cross the river, as usual, as I have taught you, time taken to cross the river. This is the first part that we have to do. And the second one, the horizontal drift, the drift in the motion or drift occurred while crossing the river. Drift occurred while crossing the river. Again, let's see how to solve this question. See here, the width of river is 400 meters. The width of river is 400 meters. So we will mark this width as 400 meters and he is sailing normal to the flow of river. So that is his speed, his velocity will be along this direction. This is the velocity of sailor, or this is the velocity of boat. So VB is equal to 4 meters per second. The river is flowing at a velocity of 2 meters per second. So this is the velocity of river, that is given as 2 meters per second. We have this given data. Now the net velocity of the boat with respect to ground will be due to the influence of both the velocity, and the boat will be moving somewhere here. This is the net velocity of the boat. That the boat will be moving along this shown direction. Let us mark this as VB, that was given as 4 meters per second. Now we have all the required data. We have made it into a diagrammatic representation. This is velocity of boat with respect to ground. We got this. Now you all see this. This is the net velocity of the boat with respect to ground. Now we have to find out. We have to find out what is the time taken. Now again, this is the vertical direction, that is the y direction, and this is the horizontal direction, this is the x direction. Now you see here, we have to find out time taken. Time taken will be simply width, as I have taught you, that is the d, and divided by the velocity along the y direction, that will be vb. So this will come out to be, width is given as 400 and vb is actually equal to 4 meters per second. So you will get 100 seconds is the time taken to cross the river. Second, what is the